Okay, so hi. So today we will discuss non-linear PD of order 1. Okay. So linear PD can be solved using the Lagrange's method. For non-linear PD, the basic method is Charpit method. You all have practiced that very well. There are four special cases of Charpit method that I'm going to discuss here. Okay, you must have read that too, but I'm again reiterating it because it makes the task very simple. If you are able to identify that we can use the special forms, then the question becomes very easy and less time taking compared to Chopit method. Okay, so Chopit method is the basic method. The all the special forms arise from Chopit method only. Okay, so this is the first thing. Okay, if you see here, the first special form is when only p and q are present in the equation. Let's say p square plus q square equal to 1, p square plus q square equal to 4, p square plus 3q square equal to something, equal to a constant. All these type of questions can be solved using very simple trick. If you write the Chirpit equation for this, you will get dp upon 0, dq upon 0, because in Chirpit method dp upon fx plus uh, p times fz hota hai. Then as the original equation is devoid of both x and z, so both the term, that is fx and fz, will be 0. So the denominator of dp will be 0. So we can conclude that both p and q will be a constant, like dp upon 0, dq upon 0 will lead to a p is some constant a, q is some constant b, and we can find the relation between a and b using the original equation. Let's say I will show you by the example also. Okay, so like here, this is not the special form because here x, y, z are present with p and q, but we can reduce it to the special form with a simple technique. Okay, what I did, I divided the whole equation by z and I wrote px by root z ka whole square, qy by root z ka whole square equal to 1. Now I want to take px upon root z as some p dash, or let's say capital P. Okay, so here I took, I know p is del z upon okay, del z upon del x. So I took del z upon root z as some dz, and it came out to be z equal to root z. Similarly, I took del x upon x, because in geometry we get del x upon x as some dx. So I will get x equal to ln x. Similarly, I can get y equal to ln y. Okay. Now the equation has reduced to some capital P square plus capital Q square equal to 1. That is the special form. Okay. Now I can simply put P equal to A, Q equal to B, and then I can solve the equation. I know that the dz equal to p dx plus q dy. Okay, now integrate. You will get uh, put p equal to a, q equal to b. You will get z equal to ax plus by plus c. Okay, this is the ax plus capital Z equal to capital small a x plus by plus c. Okay, now we know that z is 2 root z. I put that x is ln x, y is ln y. I put that in the equation. I here forgot to write b in the form of a. You can write it a ln x plus under root 1 minus a square ln y plus c. Now this question is solved in 4-5 steps. But if you were to use a Chirpit method here, it would have become a little bit clumsy. So always look for, if possible, always try to use the special form. It makes your it makes your task a little bit easier for two reasons. First, you have to write fewer equations, because Chirpit you have to write 4 or 5 equations. Then you have to check uh, by hit and trial. Here you will get very easy solutions. It will save your time in the exam. Point number one. And there are lesser chances of silly mistakes in this compared to the Chirpit method. In Chirpit method, you might make a silly mistake. Here the process is very simple, so you can easily do it. Okay, so this is the reason I recommend you always look for, if given a question and the question is not specifying that you should use Chirpit method, always look for, can we reduce the equation to any special form. If yes, then always use the special form. It will save your time and it will save your effort as well. Okay, but let's say if you are not able to use it, then obviously Chirpit method is the way to go. So this is the first form. The second form is Clayoid form. It is very simple to ODE. Okay, the Clayoid form is z equal to px plus qy plus some function of p and q. Should be purely a function of p and q. Should not be a like function of some x, y, z along with p and q. Okay, so there was a question in 1989. There are more questions on this also, but I just gave for example, like here, z equal to px plus qy plus c times c is some constant under root 1 plus p square plus q square. We can simply put p equal to a, q equal to b, and we will get the solution. Z equal to ax plus by plus c times under root 1 plus a square plus b square. This is a Clairaut form. You should know it. You should know it. And there are few questions where you the question will not be directly in the Clairaut form. You can reduce it to the Clairaut form, like we used to do in ODE. The third form is where x and y are missing. Only p, q, and z are present. Okay, so there's a simple process to solve it. Okay, the process is you take some u, you assume some u which is equal to x plus a times y, and then if you check del z upon del u will come out to be p, same as p, and del z upon del y will come out to be a times 1 by a times q. So you can write p equal to del z by del u, q is equal to a times del z by del u, and then you can put that in the original equation. You will get an ordinary differential equation. Now what you have done is, using this form, you have converted a partial differential equation to an ordinary differential equation, and you can easily solve the ordinary differential equation. Okay, for example, you can try this question. Okay, I have left this for as an exercise. You can try this question. In here you can put u equal to x plus ay, and you can then try. It won't be that messy. Then there is the fourth form where the equation is devoid of z. There is no z. P, q, x, and y are there, but there is no term containing z. Then the second thing is, it should be separated. The x and p term should get separated, and y and q term should get separated. Okay, so like here, py plus qx plus pq equal to 0. This came in civil services 1990 exam. So you can what you can do is, you can write in this form: minus p by x equal to q upon y plus q. Now here p and x are separated, q and y are separated. Now the process is, you take minus p by x as a, q by y plus q, that is the second function, as b, and then you can solve for p and q, and then you can find dz z equal to dz equal to p dx plus q dy. You can solve it that way. These are the four equations. Okay, these are four special forms that you should be aware of. And look at a question, and if the question is not asking you to solve the question by the Charpit method, always try, can we or can we not use this special form. If you can use this special form, always go for the special form. It will save your time in the exam, and it will be easier. The solution will be a little easier. I am giving you an illustration here, like this question: z square equal to pqxy. Okay, what you can do is, you can try doing it with Charpit. Okay, after this session, try doing it with the help of Charpit method, and you can see it will be a little bit clumsy. Solving it by Charpit method is a lot more. It will take a lot more effort, lot more time, but with the little tweaks, you can change it to a very simple form, that is the form containing just p and q. Okay, so what I did is, I divided the whole equation by z square, and I wrote px upon z. Why px upon z? Because p is del z by del x. So I try to separate the x terms with p and y terms with q, and then try to make it in some p dash. Okay, so px by z, qy by z. Now simply dx by x equal to dx, dy by y equal to dy, dz by z equal to dz. Okay, you can simply find x equal to ln x, y equal to ln y, z equal to ln z, and then if you make this substitution, you will get a new equation, which is pq, capital P capital Q. You can write it p dash q dash also, equal to 1. Now this is the first special form. In first special form, we know that we can simply put p and q equal to a and b respectively. Okay, so I put p equal to a, q equal to b, that is ab equal to 1, b equal to 1 by a. The solution will be z equal to ax plus by plus c. If you are you can easily get the solution, because dz equal to p dx plus q dy, and therefore dz equal to a dx plus b dy, and when you integrate, z equal to ax plus by plus some constant c. So this, that's why I have written directly in this form. And then I can replace b by 1 by, it will come out to be z equal to ax plus y by a plus c, ln z equal to a ln x plus ln y by a plus c. Very simple solution. You can try it with Charpit. It will not be this easy. Okay. So this is from this is the part of 4 special forms, and I'm emphasizing on because when I started using these forms, I saved a lot of time in the exam, and I was able to do uh, the non-linear PDs a little more quicker and with much more confidence, because I was sure that okay, if not in this way, that way I can do it. But not all question can be solved this way, because some are very complicated, which need where we need to use a Charpit method. Okay, so I'm sharing some few questions, okay, where the Charpit method gets a little more complicated. Okay, so let's move to Charpit method. Like this is the question which I found to be a very unique question. You can see the question, px minus qy equal to qx into some function of z minus px minus qy. Okay, so when you start solving this question, there are one thing that I want to there is one thing that I really want you guys to focus on, like this term. Okay, this term. In the previous session, I always told in the Lagranges to look for combination. This combination is very common, which we often ignore in the exam. It doesn't come to our mind automatically. That is x into dp plus y into dq. This is a very common combination in while solving Charpit method questions. Okay, so always look for this term also. If you're not able to make pairs, which gives you a set of solution, always try to look for this pair also. That is x dp plus y dq, because it is kind matlab this there are 40 around 40 questions of Charpit method in the MDR book, and this method is applicable to like 7-8 of the difficult questions. So in a difficult question where you are finding a little difficulty to make pairs, always look for this x dp plus y dq. There are many questions of this form. Okay, if you are not able to see a pair, always look for this also. So just mark it down that x dp plus y dq is a very important combination to look for by solving a Charpit method. So here they did the same thing. They write x dp plus y dq and it came out to be 0. That is x dp plus y dq is a constant. Okay, as simple as that. Now the picture doesn't end here. Okay, so now what they have done is they added p dx plus q dy, okay, to this. So it came out to be x dp plus y dq plus p dx plus q dy equal to p dx plus q dy. Okay, now we are aware that dz equal to p dx plus q dy. What they did is they replaced this term. Now look at this. Just highlight. Let me highlight it. In this term, sorry, first term x dp plus, that is the third term, p dx. We can make a pair and we can write it as d of xp, d of px. Similarly, y dq and the third term, right? We can make a pair y dq plus q dy, and we can write it as differential of py, and they have did the same thing. So the right hand side became pair of dpx and dq, and they have written p dx q dy as dz, as we do in the Charpit method. Okay, this is a little unique question which doesn't which will not automatically come in your mind. Okay, so mark this question. Okay, take down it in your notes, write it, because if it comes in exam, you might not be able to make these little tweaks to get the solutions. So let me tell you again. First they did was they found x dp plus y dq, and they found it to be a constant. They found it to be a 0, and then they added p dx plus q dy to the both sides, and then they rearranged x dp and p dx to make it d of xp. Okay, and similarly y dq and q dy to make d of yq, and they wrote the RHS, that is P dx plus Q dy, as dz, and then they tried to solve it. Dz minus dxp minus dyq equal to 0, that is dz equal to that is z equal to px minus qy equal to some constants, let's say a. Okay, so they have got px plus qy equal to z minus a. Now if you see in this question, okay, in initial equation f of z minus px plus qy is given, and they have, and we have already found that z minus px minus qy is a constant a. Now they put a in the original equation in f of a, and then they found the second solution, second set of solutions, like you can see in the equation, 2yq z minus fa minus x into q into function of a. Now you can easily find p, and now then you can integrate. Okay, so this question is a this, this question requires a lot of like tweaks. Okay, so note down this question and try this at home again. And there's another question that I want to share. Okay, there's one more question that I want to share. Okay, this is the question. You can, if you can see. Okay, okay, so in this question you can easily find the pairs. The difficulty comes while integrating dz. Okay, the difficulty comes while integrating dz. The terms are really complicated, where dz is y plus a upon 1 minus ay dx, 1 plus a square 1 minus a square. Okay, so here you have to make factors. So mark this question, look what they have done, just see the solution once. Okay, they have taken u equal to x y plus a upon a minus 1 minus ay. Okay, there is not much brain to put in, but in exam condition, when you are already in so much stress, you might not able to find the correct pairs and integrate it. This integration is quite complicated, that's why I have put this in the PDF. So note down this question also. Okay, especially the integration part in the question, so that if this question comes in exam, you should be already aware ki, okay, what is the process to integrate the equation. Okay, I'm just giving you 10-15 seconds to browse through the solution, then how they have integrated. Okay, moving ahead, I've already shared the PDF in the group also, so you can look at this solution. Okay, this question, this came in IS 1998. Okay, if you solve it directly using a Charpit method, it becomes quite clumsy. Okay, so what they did is, the observation here was that z accompanies every partial differential, that is del z by del x and del z by del y का whole square के साथ भी along with that also we have z square term. Okay, so what they did is they took z dz as some d of capital Z, that is z square equal to 2z, and then they tried to make it, then they tried to solve it. Okay, you can solve it, you can see here z dz dz, z square equal to 2z, then they wrote it in this manner, 2z equal to plus 2x minus del z by del x square. Okay, and then they tried to solve it. Okay, and it became quite simple after that, but if you solve it directly, it becomes very clumsy. So these are few questions that I wanted to share. I will share one more PDF where I will compile all the tricky questions of Charpit method with you. Okay, so this is from my side that I wanted to tell you guys about. That is the 4 special forms and how they are really useful in solving questions. And some tricks in Charpit. Like this one is really tricky question. You should jot it down in your notes. Okay. Okay. So now we are open for questions. Please ask if you have any doubts.
हेलो सर।
Yes.
सर कल का टेस्ट का टाइम क्या होगा? जस्ट लाइक अभी तक कुछ मेंशन नहीं करा है ग्रुप पर पीडी के टेस्ट के लिए।
Test
सो
paper
आप
test paper will be shared tomorrow uh, in the morning, and you will get the whole day to write the exam, and then you will have to share that test in the group. Okay.
ओके सो जस्ट नो टाइम
In one or
डायमेंशन,
two,
मतलब कि इन डेट पर्टिकुलर पीरियड वी हैव टू राइट।
yeah, it's better to write in that particular time. Otherwise, if you procrastinate, most of the time people miss the exam because they procrastinate. It's try to write in time. It would be better. Even if you have not done the complete syllabus, try to write that exam. It's okay. No.
Sir,
Yeah.
should we do MTR as well? Because most of the question seems repeated. So should we do the whole questions from MDR as well?
No, no need to do MDR in particular. If you have, like all the questions that are in JPR also are in MDR. Okay, so whatever tricky questions are, I will share a PDF with you in the group. Okay, tomorrow
Okay.
morning or by the noon. Just try to do those questions, and do if you are doing previous year questions, then don't try to jump books. Just do one book again.
Okay.
That would be more beneficial. Okay.
Okay. Sir. Okay.
Okay. Okay. So I don't think they are. Today the participation was quite low. So if you have any question, you can ask. Otherwise, I will wrap up the meeting. Okay, great. So I'm wrapping up the meeting. So what you should do is whatever question that I've shared in this PDF, now please try it yourself. Okay, and try this question, that is z square equal to pqxy, using Charpit method as well as transforming it to the form one, and then you can yourself see the difference, that how Charpit method is quite complicated and reduction to the special form is a little bit easier to do, but reduction to the special forms will be a little it won't come automatically to your mind unless or until you practice a lot. Okay, so practice those questions. Okay, look for questions where you have used special forms, and then when you are comfortable in it, you can just by seeing the question you can guess okay, we can reduce this to a special form. Okay, and it will come very handy, especially when the question doesn't specify to solve it by Chopit method. Then it will save your time and it will save your effort, and there are less chances of silly mistakes also. Like this question, try this question using Chopit method also. Z square equal to pqxy, and try this question using the method that I have told you, reducing it to the special form number one. Okay, and do this question, that is question number example number 26. Okay, do this question and the three questions that I've shared in the group. Okay, so I'm wrapping up the meeting. It was nice talking to you guys. Okay, bye bye.
सर थैंक यू। आई हैव गेटिंग अ नेटवर्क इशू, दैट्स व्हाई।
Okay, no issue, no issues. If you have any doubt, you can ask me in the group regarding the uh, message, regarding the methods we discussed today, or regarding the meeting, or anything else. You can always ask in the group. Thank you.
या सर, थैंक यू।
Okay, bye.